Sine,
Sine,
sum, and difference.
Sine, cosine.
Sine, cosine.
Yeah, okay, not too many co, okay, not sine, cosine, okay, just sine, cosine, all right? One more time. Sine, cosine.
Sine, cosine.
Yes, very good. Okay, next pair, cosine, sum, and difference.
Cosine,
Sum, and difference.
Very good. Change, sine.
Change, sine.
Yes, again, change, sine.
Change, sine.
You can see on the screen, right? Change, sine. Okay, next pair. Next pair we have to split up. Okay, say two different ways. All right. So let's say together here, tangent sum. Everyone.
Tangent sum.
Sum over 1 minus product.
Sum over 1 minus product.
Yes. Okay. Next one, tangent difference.
Tangent difference.
Difference over 1 plus product.
Difference over 1 plus product.
Okay, so the top numerator is difference. The denominator will be the opposite, right? It will be plus. If you see a sum, then it will be 1 minus at the bottom. Okay, the last pair, one more time. Okay, tangent sum.
Tangent sum.
Sum over 1 minus product.
Sum over 1 minus product.
Okay, tangent difference.
Tangent difference.
Difference over 1 plus product.
Difference over 1 plus product.
Okay, so make sure you spend time memorize these ones. Okay, just close the book, test yourself. Okay, sine, sum, and difference, sine, cosine, sum, and difference, change, sine. Okay, keep repeating, and then when you need to use it, you can use it very quickly. You don't have to look at the book. Okay, you just follow what you said. All right, so for one example, okay, let's do another example here, because in your homework, you will get something like this. You have a secant, right? We still want to find exact value, but you are given a secant, 7 pi over 12. So any suggestion, any idea how to do this one? We don't have formula for secant. What should we do then? Anybody? How do we start? Which identity to use?
Cosine.
Cosine, yeah, has to do with cosine, but then right now we don't have a cosine yet. How can we rewrite it then? So
1 over cosine.
Yeah. Can you say that one more time?
1 over cosine.
1 over cosine, and then what about the angle?
7 pi over 12.
Okay, so remember, you do not need to flip the angle, okay? Never, okay? You can write it on the side. We wrote this before, okay? Just one more time. Never reciprocal the angle. Okay, so if you want to rewrite this, it does not become, okay, you can write it on the top. 7 pi over 12 secant is not the same as cosine 12 over 7 pi, okay? This will be completely wrong, okay? You cannot flip the angle, okay? Never do that. So to rewrite this properly, you have to do what Eric said, right? You have to write it as 1 over cosine 7 pi over 12. Okay, and then you just focus on cosine 7 pi over 12. Okay, focus on this first. So this formula is change sine, right? So we will get the answer for the denominator. Once you get the answer for that, then you flip your answer, right? You do the reciprocal afterwards, okay? So do not reciprocal the angle. So for this one, called change sign, we need to split it first. So now it's your turn, okay? Please choose two angles, A and B, all right? And then carry out the change sign. Depending on whether you use adding or subtracting, okay, you will need to change and then final answers, all right? So let you try this all by yourself first. Well, what you get is not really final answer, right? We still need to flip afterwards. So anyways, when you get the 4 brackets, please raise your hand, all right? And then we'll go over the next step together. Find the 2 angles that makes up 7 pi over 12. Okay, let's check the combination that you chose. Right, what are the 2 angles you chose? Okay, Irae, what did you choose?
Pi over 3 and pi over 4.
Add or subtract?
Add.
Add, okay. So you will have change sign. So Kelly, did you use the same pair?
Yes.
Okay, in the same order as well?
Yes.
Yeah, okay. So what's your first bracket?
Root 3 over 2.
And second one?
1 over root 2.
Over to 2. Okay, looks good. Okay, Donna, Samantha, Tiana, have you finished the 4 brackets? Yeah. Okay, Donna, what's the sign in the middle? Add or subtract?
Add.
Add? Right. Change.
Negative.
Yes, okay. Remember, we need to do subtraction, right? Cosine sum and difference is change, sign, right? So what's the third bracket, Cindy?
I didn't realize you had to solve for that yet, so.
Okay. Okay. You need to, yeah, find the exact values. When you find it, let me know. Okay. Let me know your answer.
Jason, for the first one, I got 1 over 2.
Me too.
First one, 1 over 2. Okay. Yeah. Okay.
That could be sine though.
No, yeah. No, it has to be cosine, right? Yeah. So it should be 1 over 2. Kelly? First one should be 1 over 2. You're right. Kelly, do you know why it's 1 over 2?
Yeah, because it's cosine.
Yeah, because we are doing cosine, right? Coco. The first two brackets are for coco, right? So the picture for power 3 should be like root 3 here, 1 and 2, right? So cosine is 1 over 2. Cindy found it, third bracket.
Oh, I think I got root 3 over 2.
Okay, and fourth one?
Um,
Hmm?
1 over root 2.
Yeah, it's still the same, right? Because power 4 is the 1 root 2. So sine and cosine will be the same. Right, now we need to simplify this into one fraction. Once again, they have the same denominator, right? So we have 2 root 2. And the top is 1 minus root 3. Okay? Don't start simplifying yet, right? Because the question is secant, right? So don't start rationalize. We need to flip it, okay? So we need to go back up, right? Remember this was doing on the side. So the original question is 1 over what you got, right? The thing that you got is 1 minus root 3 over 2. Do you know what I'm writing? Right? Everything that you did just now is only for denominator. But then you need to put it back, right? And then 1 over your answer. So it will make it flip. That should be a 2 root 2. So if you make it flip, 2 root 2 will now go to the top. And then denominator will be the 1 minus root 3. Okay, so that's how you deal with the secant. And then you would rationalize from here. So Kelly, I'll let you practice this one. How do we rationalize this one? What do we multiply with?
Root 3.
Okay, take a look at the denominator. How many terms?
Oh, there's 2.
Yeah, so we should use
1 minus root 3.
the question has 1 minus root 3, so you should do the opposite sign.
1 plus root 3.
Yeah, okay. The 1 minus always pair with the 1 plus. They are conjugates to each other. So top and bottom will be the same thing. And then you use the a squared minus b squared formula. Okay, so the denominator will now become what? Tiana, what's the denominator then?
Is it 1?
1? Just 1?
Yeah.
Okay, the denominator I'm talking about is these two, right? The one in the blue brackets, 1 minus root 3 times 1 plus root 3. You need to use the difference of square. Where do we put it? Where do we put it? Here. Right? Remember a plus b times a minus b. You need to do a squared minus b squared. Okay? So can you try again? How do we get the denominator? Do you know how to get it, Tiana?
No.
Okay. The 1 minus root 3 is like the a minus b. You follow?
Yeah.
Yeah, okay. And then 1 plus root 3 is like the a plus b, right?
Mm-hmm.
So what happens when you multiply those two together?
A square minus B square.
Okay, so what's the a squared equals for this example?
1.
1 squared, right?
Yeah.
Okay, minus b squared. What's the b squared then?
Cube root square.
Where? Say that again.
I mean, root 3 square.
Yes, okay, root 3 squared. So what's the result then? Simplify that.
-2.
-2, yes. Okay, so 1 squared is 1, right? Root 3 squared is 3, so 1 minus 3. Right, now numerator is just expanding it, right? You can multiply, distribute. So what do you get? Cindy?
Hi.
Hello.
Two,
Yeah.
two,
2. Say again.
2 root 2
Yeah, and then?
plus 2 root 6.
Yes, okay. So 2 root 2 plus 2 root 6. Will that be the final answer? Donna?
No,
All right, okay, we can simplify more. How do we do that?
you delete the 2.
Delete the 2. Okay, what about the negative sign then?
No, you
Huh?
leave it.
Leave it. So what do I need to write then?
Negative bracket root 2 plus root 6 bracket.
Okay. Okay, yeah. You could do it like that, right? And then you have a bracket, but still not simple enough. So usually just divide by -2. That'll be easier. 2 divided by -2, so it'll be negative root 2. And then another negative, so that makes it minus. Okay, so your final answer, final box should be this one. This is for secant. All right, so when you get a question that has a secant, or the next one is like a cotangent, you got to do the denominator separately, right? Once you get the answer, right, for the denominator, which is the green circle one, then you flip it, right? Flip it, then you start to simplify, okay? Right, so we won't do the cotangent, okay? I want to look at question 31 now. Any question about question 30? Are we all good? Okay, because you will get practice like for something like this, okay? It could be secant, cosecant, or cotangent, right? So you can look at this example as a reference, okay? How to do this. Right, let's look at 31. Okay, so this one is a bit different now. Eric, could you help us read this out? Question 31A.
If angle A and angle B are both in the second quadrant, sine A equals 3 over 5 and cosine B equals -5 over 13. Evaluate cosine A plus B.
Yeah, okay, thank you. So it wants you to find cosine A plus B. But the problem is we don't even know what the A and B's are, right? So what do you think we should do then? How do we start this question? Any suggestion? Because normally if I want to find cosine A plus B, right? Like this one, cosine pi over 3 plus pi over 4, we need to know the angle, right? Once we know the angle, then we can draw the angle out, get the reference, get the sides, right? Then we can write out the ratios. But here, we don't have the angle. So what should we do?
You have the quadrant, so you can draw the triangle and use Pythagoras.
Okay, we could draw the angle out first. Yeah, they do tell you the angles in second quadrant, right? So we can draw it out. Let's draw it out first. So they are both, right? Both in second quadrant. Let's write it separately. Angle A, angle B. Angle A is in second quadrant, right? Angle B is also in second quadrant. They are probably different angle, right? So let's make it different. Okay. And then what did you say after that?
Use the ratios to um, write out two sides.
Use the ratio to write out the two sides. Okay, so let's take a look. Sine A is 3/5, right? The first ratio that we are given. Where do we put the 3? Tiana? 3 and 5, where do we put them?
3 is opposite
Mm-hmm.
and 5 is hypotenuse.
Okay, so let's put that there, 3 and 5. Okay, now what about angle B? Ire?
What?
What do we put in the picture then?
5 and 13
And where does the 5 go?
on the triangle,
Yeah, which part of the triangle?
the bottom one,
The bottom one, so which side?
but bottom line.
Okay, that's called the adjacent side. Okay, what about 13? Where do you put them?
Hypotenuse.
Yes, there we go. Okay. Now what? We put everything in now, right? We drew the angle, we fill in the sides. How is that going to help us find cosine A plus B then? What's the next step?
Use Pythagoras.
Use Pythagoras. Okay, so you want to find the last missing sides. Okay, so you guys try it, right? So each triangle we have one missing side. Please use Pythagoras. Find the last one. Okay, when you find the last side for both triangle, raise your hand. And remember, no decimals, okay? We want to get exact values here. So if there's square root, right, keep it in square root, right? If it's like root 5, you leave it in root 5. Okay, Donna, angle A, what's the last side?
4.
4, okay. And Cindy, what's the last side for B?
12.
12, okay. So of course my picture is not drawn to scale, right? My 5 is longer than the 12. That's okay, okay, you know it's the 5 and 12 there. Now what? We got everything there, now what? What should we do now? We're filling everything, right? We filled up all the picture. What's there to do? What's that got to do with the questions?
You use your calculator to find the answer.
Calculator, and so can you tell me what to put into the calculator?
The negative sign thing and then 3/5.
Oh, so you mean the inverse?
Yeah.
Okay, to find the angle, is it?
Yeah.
Okay. Is the 3 and 5 special angles? Is the angle going to be special, like 30 degrees, 60 degree, those ones?
No.
No, right? The size is not. So if you use a calculator, it's gonna be some decimals, which means it's not going to be exact, right? So we are not using calculator here. The ratio, they are not special. Other ways, any other ways? So we
You
don't want to find angles here, all right? Yeah, Donna?
use the cosine, wait, the cosine sine.
Okay, we can start using change sign. Let's take a look what it becomes, right? Cosine sum, right? Cosine sum and difference is cosine, change. So add or subtract, Donna?
Subtract.
Yes, okay. Change, sine. Okay, sine. And what do we put in the brackets then? Yeah, what do we put inside the brackets? Because normally we would have angles, right? We need to sub in the angles, right? Take a look at our very first examples. Right, look at the very first one up here. Right, Coco. Okay, maybe we can look at the Coco change signs right here, right? I have the angle A, I have angle B, so I fill in the angles, right? Pi over 6, pi over 4. Then I can get the ratios for each one. What about now? What are we going to put inside the brackets then?
You use the pictures.
Use the picture, but the picture is telling you the sides, right?
Yeah.
But in the brackets, they are supposed to be angles. Okay, so the common mistake is to start to write, for example, like 3 over 5 and then put it in there, right? Remember, you cannot do that, right? In the brackets, it has to be angles. But we don't know the angles, right? So we just write A, B, A, B. That's all, okay? It's a trick question. Because you don't want to find angle. Angle is going to be a decimal. And the question doesn't ask for what is angle A, what's the angle B, right? It's asking for exact value, right? Cosine A plus B. So once you get here, you can start finding their sides, okay? So for example, cosine A, how do we get cosine A now? Ray?
By using the diagram,
Yeah, and what would that tell you to write? Cosine A.
4 over 5.
That's it? Just 4 over 5?
I think, I don't know.
Are we missing anything, anyone?
Negative.
Negative, very good. Okay, remember, find exact value. Your last step is to check sign. So be careful. And also what you could do is, so that you don't forget to add a sign, you can put it in the picture, right? On the left side will be -4, right? Because it's on the left. So x will be negative, right? Same with angle B. So that way, you won't forget the positive negative sign. Okay, so let's look at cosine B. Cindy, what is cosine B then?
Is it just -5/13?
Yeah, very good. So you look at the picture for B, right? And sine A, what is sine A? Kelly?
3 over 5.
Yeah, 3 over 5. All right, sine B. Samantha, what is sine B?
12/13.
Yep, 12 over 13, opposite over hypotenuse. So of course, the final step is to get the answer, okay? Combine, multiply, and subtract them. So raise your hand if you have the final number. So I think this one is something over 65, right? We have a denominator of 65. Cindy, what do you have?
Negative 16
Negative 16
over
65?
Yeah.
Yeah? Okay, how about Eric? What do you have?
I have the same thing.
Same thing, okay? Yeah, this one should be no problem here, right? So remember, when you get this question, right, even though it's Coco Ching sign, they can ask you in a different way, right? Try to find the answer. So you still find Coco Ching sign, but you are not given angles. And that's no problem, right? Because you don't care about what the angle is. They gave you the sides. Okay, so first you got to figure out the sides, right? First step, you find the sides. Second step, you figure out the formula to use and then plug it in. And remember, do not put the sides into the cosine, right? You just leave them as A, B, A, B. All right, so we have a similar question on the right side. So this time it's by yourself, okay? So once you can go all the way, okay, all the way to the end. So finish all the question B, we'll check the final number, all right? So raise your hand if you get the final result. I just change the numbers, okay, and then change the quadrants as well. Any questions so far, anyone? Fourth quadrant. So make sure you put them at the right place, okay, at least. as being fourth quadrant. So you don't need calculator here, right? You don't need to find the angle. Please raise your hand if you got the answer. Okay, let's check some of your answer. Okay, almost done. I'm gonna fill out the picture, okay? At the same time, you can check if your pictures looks the same. So angle A, opposite over hypotenuse, right? Angle B, adjacent over hypotenuse. So I would like to know your missing side, okay? What do you get for the missing side? Eric, what do you have for the missing side in angle A?
I have 2 root 2.
2 root 2. Okay, very good. Came from root 8, right? Simplify it, 2 root 2. Cindy, what about B? What's the missing side?
I got root 21.
Root 21, that's good. Yeah. Okay, and then the question wants to get tangent difference. Okay, since we have repeated many times, right? Tangent difference will be difference over 1 plus product, right? Okay, if you finish the final answer, please raise your hand. Any question, Kelly, Samantha, Tiana? How are you guys doing? Almost done? Or you have questions?
Almost done. I just messed up a number.
Okay. Tiana, Samantha, are you doing okay?
Yeah, I'm simplifying it.
Okay. The last step, right? Once you fill in the numbers, right? You got all the number in the brackets, then you can just put into calculator. It's fine, okay? We just get the final answers. But make sure when you type it in, you have to type it properly, right? Calculator can also mess up. Okay, Cindy, what's your final number?
50 root 2 minus 18 root 21 over 11.
I mean the final answer.
Like, and
One in the box? Can you say one more time? What's the answer again?
they like the decimal version of it.
Not the decimal, the exact values.
Oh, 50 root 2 minus 18 root 21 over 11.
Oh, like this?
Yeah.
Yeah, okay. Donna, what about you?
I don't know.
Yeah. You can tell me.
Actually,
Different from Cindy's?
yeah.
Yeah. Can I see? Can you tell me what you have?
No.
Come on. It's okay.
Wait, I probably didn't finish it.
Okay. Iray, what's yours look like?
I got 18 root 21 minus 50 root 2 over 11. It's probably wrong, but
The
like,
opposite. Flip around, huh? Okay. Oh, because this one has the square roots, right? So that's why it's a little bit difficult to simplify. Yeah, you're right. So calculator probably won't help, right? Okay, and Eric, what about you?
I got the second one.
Huh?
I got the second one. The
Second one.
18 root
Okay, so
21.
the 18 comes first. All right, so
Yeah.
let's go over the brackets then, okay? Tiana, what do you have in the first bracket on the top?
1 over root 8. 1 over 2 root 2.
Okay, that's it? Just 1 over 2 root 2?
Yeah.
Did you forget some?
Oh, yeah. Wait. Negative.
Yes, okay. Fourth quadrant, very tricky, right? If you don't want to forget, right? Maybe in your picture, you're adding the sign, right? Going down is negative, going down is negative, right? So that way you don't forget to check sign, right? Last step is check sign. Okay, Cindy, what about second bracket on the top? Cindy, yeah, what's the second bracket on the numerator?
root 21 over 2.
Did you put negative?
Oh, I forgot to do negative.
Yeah. Okay, we need to have negative, right? Because it's in fourth quadrant, you have to check sign. All right, and then now the bottom part is the same thing except they are product, right? You are multiplying them, right? So we just copy them down, right? Negative root 21 over 2, just copy them into the same brackets. Now the next job is to simplify, okay? So let's see, how do we simplify this, all right? So we have negative 1 over 2 root 2 plus, right? Because minus a negative, root 21 over 2. Now denominator will be 1 plus, the product here is negative times negative, so that will become positive, root 21 over, then multiply, so that will give you 4 root 2. Okay, so now to simplify this, looks very confusing, right? To simplify this, remember we can refer back to the way we simplify this one. The one with the tangent, right? We had an example before, right? If you get fraction in the top and bottom as well, we can multiply by the common denominator, right? In that one, we multiply by root 3. So for this one, we could multiply by 4 root 2, okay? Common denominator will be 4 root 2, right? Because the denominator at the bottom is 4 root 2. So I'm going to multiply by 4 root 2, 4 root 2. Maybe you did it a bit differently, okay? But that's okay. At the end, you should get the same. So the top, if we distribute the 4 root 2, you'll get negative 2, because the root 2 cancels out, plus, and then 2 cancel with the 4, so 2 root 42. Any questions so far? Right, and then the denominator, same thing with distribute, you get 4 root 2 plus root 21. Okay, so far we don't get any match yet, right? Because we still have square root in the denominator. So we need to times it by conjugate. Okay, so this is more work than we expected, right? So let's multiply by conjugate here. 4 root 2 minus root 21. 4 root 2 minus root 21. So then the denominator, right, if we use a squared minus b squared, that'll be 32 minus 21. Right, looks like you guys got 11, right? 11 matches, very good. Okay, and then finally the top, you need to do distribution, right? One by one, slowly, right? Distribute. Okay, let me take your answer, move it down a bit. Okay, so that will be negative 8 root 2, and then plus 2 root 21, and then plus 8 root 84, right? And then minus 2 root, wow, that's a big number. 21 times 42, 882. Okay? And then we need to simplify it. Denominator is 11. Okay, 84, we could simplify it, right, into square root of 84, we can take out a 2, right? So that makes it 16. Okay, and then 882, what can we take out? 882 divide by 2, divide by 3. We can take out the 3. We can take out 21. Right? We can take out 21. Okay, so if we take out 21, that will be 42 root 2. Okay, so looks like we have a match, right? 2 root 21 plus 16 root 21, that will be 18. Okay, and then the last ones, that will give you minus 50. Yeah, so a lot of work goes into the simplifying, okay? So if you got this one right, I'm very proud of you, okay? You've been very careful about simplifying the rationalizing, okay? It's pretty hard at simplifying here, okay? So the correct answer should be this one, but the first one is really close, okay? Just missing by a sign. Okay, I think I want to go one more, okay? Go over one more questions and then we'll call it a day. So the last question I want to do is the one over here, okay? Question 34. Okay, question 34 asks you to simplify, right? Because this one has 2 terms. I want to simplify them into a shorter version, okay? So from here, you can see that we have 2 parts. This is sine of sum, right? We have sine of sum. This is another sum. Sorry, this is a difference, right? So we can apply the sine of sum and apply the sine of difference. So it's like using 2 identity in the same questions. Okay, so I would like you to expand this. I'm gonna use different color, okay? So for the red one, you use sine cosine. The green one is another sine cosine, right? So please expand this first, okay? Plug into the formula. Sine, okay, I will use red, okay? Sine, should be same sign, right? Sine. Plus another sine cosine. Sine, minus this time, sine. Okay, and then you just fill in the angle that they give you, okay? The AB, fill them in. Okay, can you raise your hand if you have already filled in the brackets? So red part, refers to the red section, okay? And the green color refers to the green part. Okay, once you filled in everything, right, raise your hand and you can continue think about how to simplify. Okay, you need to apply the identity first so it expands and then see anything you can simplify. Okay, so your A is X, B is power 3, right? You just go in order, right? And then same thing here. A, B, okay? Pretty easy. It's just applying sine cosine twice. Okay, so please take a look. Is there any part you can simplify here? Anyone? Anything that you see special that you could simplify? Anything that's unique, stands out? Anything you noticed?
The cosine x sine pi over 3.
Yeah, what about that?
There's a positive and negative.
Yes, so what will happen to them then?
It will cancel.
Very good, okay? So you have a positive cosine x sine power 3. It's going to subtract with the same one. So those two are gone, right? So you won't see that unless you apply sine cosine, right? So you expand it, then you see, okay, they are opposite, so they are gone. Anything else you could also simplify? What about the leftovers? What can we do with the leftovers? Any suggestion? Anyone? Anybody?
Do 2 times sine x cosine pi over 3.
Yeah, okay, because they are the same, right? Since they are the same, we can add them up. So you get double of sine x cosine pi over 3. It's much shorter now, right? But I'm still not satisfied. What else can we do to simplify even more? Anything else we learned that you can do more? Can we find something here still? We are gonna stay overnight if you don't tell me. Because I know you know this. Okay, take a look. We have 2 sine x cosine pi over 3. Is there any part we can still do something? I'm not gonna say anything. Should I play some music then to help you think? Is there any part here I can do more? Hello? Are you guys thinking or having dinner now? What are you doing? Staring at it, okay? Look at it. Is there any part that I can do more to simplify? Kelly, what do you think?
I don't know.
Okay, Tiana?
I don't know.
You ready?
I don't know.
Really? Nobody?
Do you do cosine and then pi over 3?
Cosine pi over 3. Can we do something with cosine pi over 3? Did we learn anything about finding cosine pi over 3? Did we?
Yeah.
Yeah, right?
1 over 2?
Cosine pi over 3 is what?
1 over 2.
1 over 2, okay? So I can do more. So 2 times sine x times 1 over 2. And what would that equal then?
Sine x.
Sine x, okay? So that will be as far as you need to go, okay? So that's called observation. Sometimes you need to keep on pushing, right? What can we do? Is there any part we can still find it? Okay, so let's call it a day, right? You guys been very good. I'll post the homework later, okay? If you have questions, you can stay after class. And Tiana, if you want to ask me about your summer homework, okay, you can stay too, okay? Okay, so you guys have a good night. Have a good weekend.
Bye.
Okay, bye-bye.
Bye.
Bye-bye.